Okay, so the second section of Chapter 4 is talking about the unit circle. And the unit circle is just a way of remembering the values of the trig functions. And these are the trig functions between, well, nominally between 0 and 2 pi. So one full rotation. It's called a unit circle because it has a radius of 1, and as a consequence the coordinates on the unit circle are the values of the sine and the cosine for the given angle. So we've used theta as a way of looking at angles. We also can use t in this case. T stands for theta, I guess. So, you know, there's one thing is you can memorize the entire unit circle, which you'll forget soon. So I'm going to talk about these problems, how I would do them without having to memorize the unit circle. I'm probably not going, well, yeah. So just want to give you a background on why I'm doing it the way I'm doing it. So, you know, the first thing to do is to draw a circle, which has a radius of 1. And what it turns out is that the sine of the angle theta, or in this case t, is equal to the y-coordinate, and the cosine of the angle theta, or t, is equal to the x-coordinate. So when you're in the first quadrant, x and y are both positive, so you get the sine and the cosine are positive. In the second quadrant, x is negative, y is positive, so you get a negative cosine and a positive sine. In the third quadrant, they're both negative. And in the fourth quadrant, x is positive and y is negative. And the values of the trig functions, the cosine and sine, take on one of five values: 0, a half, square root of 2 over 2, square root of 3 over 2, and 1. So that's what they have to be. And when you are right in the middle, that's when you're the square root of 2 over 2. So all of these angles that bisect the middle of the quadrants, those are going to be, they have the same x and y coordinates, so they're going to both be the square root of 2 over 2. Now usually the question is, you know, which is which? Do I have a half for the other angles, which involve sixths or thirds? Is it going to be a half or the square root of 3 over 2, or is it going to be plus or minus? That's kind of what the unit circle does and helps us figuring those things out. So back in the old days, you remembered these five values. You know, on the axes, and to figure out, you know, whether it's a half or square root of 3 over 2, if you take the square root of 3 over 2, the actual numerical value, square root of 3 over 2, is equal to 0.866. So it's very close to 1. So if you go over here to pi over 6, which is here, you'll notice that if I go down, this value, the x value, is very close to 1, whereas the y value is about a half. Likewise, if you go up here to pi over 3, which is right there, if you go over to this axis, that's very close to 1, and then this one, I didn't draw that quite right, but it's obvious which one's really close to 1 and which one's more in the middle between 0 and 1. Okay, so we're going to use that to help us figure these things out. So we're going to start off with all we really need is these three pieces of information. We need to have a unit circle. We need to know the values are either 0, a half, square root of 2 over 2, square root of 3 over 2, or 1, and the y-coordinate is the sine and the x-coordinate is the cosine. Okay, so let's come over here and do this one first. So you've got 7 pi over 6. So 6 pi over 6 would be right here. So we just go 1/6 more. So that's going to put us right here. So that's 7 pi over 6. Okay. Now, if I draw up vertically, this one's very close to 1, and this is right in the middle. So what I can say is that the x-coordinate is going to be this square root of 3 over 2 term in terms of the size, and the y is going to be equal to a half, but because I have a negative x-coordinate and a negative y-coordinate, I'm in the third quadrant, they're both negative. So what I can say is that the cosine of 7 pi over 6, which is the x-coordinate, is going to be negative the square root of 3 over 2, and the sine of 7 pi over 6 is going to be negative 1/2. Okay, so let's erase all that stuff and do the next one. So 5 pi over 3. So where does that land? So 6 pi over 3 is 2. So it's going to be close to here. So one way you could think of it is, if you take 6 pi over 2 and you subtract, say, 6 pi over 3, 6 over 3 is 2, so it's 2 pi. 2 pi minus 1/6 is going to give me 5 pi over, am I doing this wrong here? Oh, it's because I'm going to subtract a third here. So 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. So one way I can think of it is I can go this way, 5 pi over 3, or I can go this way, 1/3 pi. That's one way of thinking about it. Another way to think about it is if you take 3 pi over 2, which is the negative y-axis, and you add pi over 6, and so 3 pi over 2 plus pi over 6, so this is 3 pi over 2 in terms of, that's 9 pi over 2 plus 1 pi over 6, 9 pi over 6, sorry, 3 pi over 2 multiplied by 3, you get 9 over 6, 9 plus 1 is 10, so you get 10 pi over 6, which reduces down to 5 pi over 3. So we can go this way all the way to here and a 1/6 of the way between these two places, or you can go all the way around and then come back 2 pi. So this would be, not pi, come back pi over 3. So this would be pi over 6 and pi over 3. So that's the angle right there. So that is 5 pi over 3. So we've got it drawn. That's the first step, is to draw where the angle is. And then if you take the x-coordinate, you go up here and you see it's right in the middle. You take the y-coordinate and you find it's right over here. So I know that the x-coordinate, which is in the middle, is going to be 1/2, and the y-coordinate, which is going to be close to 1, is the square root of 3 over 2. But because I'm in the fourth quadrant, x is positive, but y is negative. So from that, I can say that the cosine of t, which is the cosine of 5 pi over 3, is equal to the x-coordinate, which is 1/2, and the sine of t, which is the sine of 5 pi over 3, is going to be the y-coordinate, which is negative the square root of 3 over 2. Okay, same thing here. We've gotten angles. We've got one additional request, which is figure out the tangent. But once you have the sine and the cosine, you can do the tangent in a number for using a number of different possibilities. So let's start again. Here's our coordinate axes. Here is our circle. And remember, the x-coordinate is the cosine. The y-coordinate is the sine. And it's going to take on a value either 0, a half, the square root of 2 over 2, square root of 3 over 2, or 1. So here we have t is pi over 3. So that's, remember, this is pi over 6, this is pi over 3, so that's pi over 3. So we have approximately where it intersects. You go over to the y-axis, you go down to the x-axis. You can see this is going to be a half, so we can say the cosine of t, or the cosine of pi over 3, which is the x-coordinate, and that's going to be a half. And the sine of t, which is the sine of pi over 3, is the y-coordinate. And you go up here, and the y-coordinate of this point on the unit circle is going to be the square root of 3 over 2. And they're both positive, positive x, positive y. So those are the sine and the cosine. Now, to find the tangent, what you can do is you can take the ratio of, turns out the tangent is the sine divided by the cosine. So if we take the sine, which is the square root of 3 over 2, divided by the cosine, which is a half, we get that. And if you're dividing by a fraction, you take the reciprocal and multiply it, so those cancel out, and you end up with the square root of 3. So those are the answers. The sine of t is the y-coordinate, which is the square root of 3 over 2. Cosine of t is the x-coordinate, which is a half. And the tangent of t is the ratio of the two, which is the square root of 3. This is sine or cosine. Another thing you could remember is the tangent is either 0, the square root of 3 over 3, 1, square root of 3, and undefined. Those are the values that it takes on for these key points, pi over 6, pi over 4, pi over 3. And they always go in this order. So our case, we had pi over 3, which is the square root of 3. So you get the same answer that way. Okay, let's erase everything here that we're not supposed to memorize and just stick with these three things. The unit circle, this relationship, and these values. So we got to figure out where we are. So remember, we found using 7 pi over 4, and then we're going to reflect it over the x-axis. So this is going to be one of these quarter points because it's divided by 4. So it's either going to be here, 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 or here. Let's see where, we have to figure out where it is relative to these coordinate axes. So the 7 pi over 4 is greater than 6 pi over 4, and it's less than 8 pi over 4. Well, 6 pi over 4 is 3 pi over 2, and 8 pi over 4 is 2 pi. So we see it's in the fourth quadrant. And because it's divided by 4, it's going to go right. It's bank in the right in the middle. Okay, so that's 7 pi over 4. So negative 7 pi over 4 is up here. What's happening is, 7 pi over 4, we go this way. Negative 7 pi over 4, we go the other way. So you can see that that's my point on the unit circle. Once I've drawn that, and now it's a piece of cake because these quarter points are the square root of 2 over 2 for both of them. You go over here and you get the same value. So we know that the sine of t is equal to the square root of 2 over 2, because we're here, positive. Cosine of t is square root of 2 over 2. And then the tangent of t is the sine of t divided by the cosine of t. And since they're the same, the ratio is 1. So the tangent of t is equal to 1. Now it's nice that you can actually check your answers without using the unit circle by plugging into your calculator. So if we did the sine of negative pi over 7 pi over 4, let's just do that. You got to make sure your calculator's in radians. So if you, which mine's not, so I'm glad I checked that. So if I do the sine of 7 times pi, well, actually I have to do negative 7 times pi divided by 4, what I get is 0.707. So my calculator would say 0.707. And if I do the same thing, except I do a cosine, I get 0.707. And if you look at the decimal equivalents of these, you get 0.5, 0.707, 0.866, and 1. Okay, so that's square root of 2 over 2 is that. Calculator worked. You can do the same thing up here if you wanted to do the sine of pi divided by 3. You would get 0.866, which is square root of 3 over 2. If you do the cosine, you get 0.5. Okay, now it's asking for all 6 trigonometric functions. And looking at the book, what they do is they, instead of doing the sine over the cosine, they just do the y coordinate over the x coordinate, which is the same thing, because I'm saying x is the cosine and y is the sine. So you can do the same thing there. Now, to find the secant and the cosecant, instead of the sine of t being equal to y, say that the cosecant, which is 1 over the sine, is going to be 1 over y, and the secant, which is 1 over the cosine, is 1 over x. So it's not hard to find them once you figured it out. So again, here we go. Draw our coordinate axes. Draw a circle, radius 1. Y equals the sine of x, x equals the cosine of x, and the values are 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Okay, so let's see where we are. 5 pi over 6. Okay, 6 pi over 6 is 1. So 5 pi over 6 is just 1/6 less. So here's 6 pi over 6. Here's pi over 2, 3 pi over 6. 5 pi over 6 is going to be right there. So we go 1/6. This is 1/6, 2/6, 3/6. So we go 1/6, about right there. Okay, so that's the point on the unit circle. So here's our x coordinate, here's our y coordinate. So you see y is positive, x is negative. So we're going to say the sine of 5 pi over 6 is equal to the y coordinate. The y coordinate is is a half because we're right in the middle here. So it's plus, it's going to be a half or 0.5. I'll use a half. And the cosine of 5 pi over 6 is equal to the x-coordinate. And you can see the x-coordinate is close to 1, so it's this square root of 3 over 2, except it's on the negative x-axis, so it's going to be negative. So we can say that the sine of 5 pi over 6 is equal to 1/2. The cosine of 5 pi over 6 is equal to negative the square root of 3 over 2. The tangent of 5 pi over 6 is equal to y over x. So that's going to be 1/2 divided by negative the square root of 3 over 2. So you see what happened. The 2's cancel out, and you end up with 1 divided by negative the square root of 3. If you multiply and divide by the square root of 3, you get the square root of 3 over 3 with the negative sign. So that negative sign becomes that. Square root of 3 times the square root of 3 is the square root of 3. So the answer is the tangent of 5 pi over 6 is equal to negative the square root of 3 over 3. And then the other ones are just the reciprocal. So we know that the cosecant of x is 1 over y, because the cosecant is the one that's opposite the sine. So that becomes 2. So you get 1 over 1/2 is 2. The secant, which is the one linked to, and this should be the cosecant of 5 pi over 6. 5 pi over 6. So the secant of 5 pi over 6 is equal to 1 over x, which is 1 over negative the square root of 3 over 2. What you do is you take the reciprocal of the denominator. So you get 2 divided by the square root of 3. So you get negative 2 divided by the square root of 3. Multiply the numerator and the denominator by the square root of 3. So you get negative 2 times the square root of 3 over 3. So that's the secant. And then the cotangent of 5 pi over 6 is equal to x divided by y, instead of y divided by x. So we get x is the square root of negative the square root of 3 over 2 divided by 1/2. That's the y coordinate. And you see the 2's cancel out, and I just end up with negative the square root of 3. Okay, so that's that problem. So if you want to pause, because I'm going to delete that if you want to copy everything down. Actually, what I need to do is delete that page, because I'm coming back to my thing, get rid of everything that's specific to this problem. Keep the 3 things I need. Okay, so where is this? 4 pi over 3. So 4/3 is greater than 3/3. So this is 3 pi over 3. It's 1 pi. And so that's 1/3 more than 4/3. So 4/3 is 1 more than 3/3. And the thirds, this is 1/6 added. This would be 2/6 or 1/3 added. So that's the location of 4 pi over 3. That's this angle. And so here's our y coordinate. Here's our x coordinate. So you see the x coordinate is going to be 1/2, negative 1/2, and the y coordinate will be negative square root of 3 over 2. So let's write that down. So the sine of 4 pi over 3 is the x coordinate, which is negative 1/2. That's the y coordinate, sorry. That's why you write them down so you don't forget them. So the sine of t, I guess, really should be sine of t. So the sine is the y coordinate, which is the square root of 3 over 2, but it's negative because it's along the negative y-axis. Then you've got the cosine of 4 pi over 3, which is the x-coordinate, which is negative 1/2. Tangent of 4 pi over 3 is y over x. So this is the y, so you get negative the square root of 3 over 2 divided by negative 1/2. Notice the halves cancel out, and the negatives cancel out, so you just get the square root of 3, positive. So the tangent is positive in the third quadrant. Okay. Next, cosecant of t, which is 4 pi over 3. Take the reciprocal of this, which is negative 2 divided by the square root of 3, multiply by the square root of 3 over the square root of 3. So you get negative 2 times the square root of 3 over this 3. Yeah, so the sine and cosine have the same signs as the secant and the cosecant. Now here we have it the other way around, which is, so we have 1 over x for the secant, so you get 1 over negative 1/2, which is negative 2. And remember, the sine and the cosine are always between negative 1 and positive 1. The cosecant is always greater than 1 or less than negative 1. And then you have the cotangent of 4 pi over 3, which is going to be x over y. So my x is the cosine, and the y is that. So the 2's cancel out, the negatives cancel out. We should end up with a positive result because the cotangent and the tangent always have the same sign. So we end up with positive 1 over, actually it's, it's going to be 1 divided by the square root of 3 times the square root of 3 over the square root of 3. So you get the square root of 3 over 3 for the cotangent. Evaluate the trig function using its period as an aid. Okay, so these are all greater than 2 pi. So what you want to do is you want to get them such that t, which is the argument, is between 0 and 2 pi. So all you have to do is take the original argument, which is greater than 2 pi, and subtract 2 pi. That'll give you 3 pi. Well, that's still greater than 2 pi, so you subtract 2 pi again. Every time I subtract 2 pi, I'm going clockwise, a full rotation. So this becomes pi. So this is the same as the sine of pi. So if we draw a unit circle, pi is right here. So here's the positive x-axis, here's pi. So what's the coordinate? Well, remember the sine of t is equal to the y-coordinate, which in this case is 0, the y-coordinate of that. So the sine of 5 pi is 0. And again, you can check it on your calculator. If you just do the sine of 5 times pi, you get 0. So I'm not encouraging to just use your calculator. you'd still have to draw things and do these, show show you the logic behind it. But I wouldn't be against you using your calculator to check your answer. Okay, now here we have the next one, which is 9 pi over 4. And 9/4 is greater than 2. So what we do is we subtract 2 pi again. So that's 9 pi over 4 minus 2 pi, which is 8 pi over 4. So 9 minus 8 is 1, so you get pi over 4. Okay, so now we're between 0 and 2 pi. So we draw our axes. Here's our unit circle. Pi over 4, it's one of those 4 ones, so it goes right in the middle. This is pi over 2. This is 0. So the x and y values are the same, so it's going to be the square root of 2 over 2. So the sign of 9 pi over 4 is the same as the sign of pi over 4, which on the unit circle shows that it's the one where they have the same value, and it's in the first quadrant, so they're both positive. Okay, now what we're going to do is we're given the cosine of t or negative t, and we're going to place that in the, figure out where that is on the unit circle. And from that we can, once we know where it is on the unit circle, we can do the others easily. We can figure out what the other stuff they're asking us for. So this takes a little more insight. Let's draw our unit circle. So remember, when you have a negative sign here, you reflect across the x-axis. So let's plot the cosine of negative t, and then we can just flip it over. So so you've got a negative. It's either going to, the cosine is negative in the first or the second or the fourth quadrant. So let's just draw that. And it's going to be 1/5. So the x value is 1/5. So here's 1. So we go, but it has to be over here because it's negative. So it's going to be negative 1/5, which is about here as far as the x. So it's going to be here. That's the direction I have to get. So we intersect it at negative. And it could be both, either one of these. Both of these have an x value of negative 1/5. So because I said the negative sign here means you flip it across the x-axis, you can see that nothing changes. This one will go up there and this one will come down there. So so in either case, the cosine is still going to be the same. If you go from here up to here, it's going to still be negative. So the answer is negative 1/5. And the secant of negative t, all we have to do there is, if the cosine of negative t is this negative value, then the secant is just, you just flip those around. So it turns out to be negative 5 for that answer. Okay, let's do the next one. And it's actually in your book. It says that the cosine of negative t equals the cosine of t, so those are the same. And then it says the secant of negative t equals the secant of t. So anyway, that goes along with it. Now the question of how do you handle the pi part? I'm just trying to make sure I do it the way that the book allows me to do at this particular point. So you can see what's going to happen is if I, let's just see what's going on here. So let's say we have some angle T. So this is my angle T. So then if I take, if I want this pi minus this angle, that's going to put you here. And if I take pi plus this angle, it's going to be there. So this would be pi minus t, and this would be pi plus t. So you can see they have the same x and y values, except the signs are different. So if I have a cosine of 4/5, that means I'm over here. I'm either in this quadrant or this quadrant. So I have a positive cosine, that means I'm here. So if I take pi minus t, that means I'm going to be over here instead. So my x-coordinate goes from positive to negative, so I get negative 4/5. And the same thing here, I'm still in the same location, so it's negative 4/5. Okay, next part's piece of cake. So you just enter those in your calculator. So I'm going to write it out as I'd enter it. So you have this tangent function, and then you put in the pi, and then you do /3. So let's just put that in there, make sure you get the right answers. If you don't, you can come and see me. Tangent of pi /3 divided by 3, and you get 1.732. And if you remember from previous problems, the tangent took on values of 0, the square root of 3 over 3, 1, the square root of 3, and undefined. So these are going in increasing numerical order. So it looks like 1.732 should be the square root of 3. Let's just check that out. Square root of 3 is 1.7. Yeah, so it is. So it's equal to square root of 3. The cosecant of 0.8. Again, you got to make sure your calculator is in radians. The cosecant is 1 over the sine of 0.8. So we take 1 divided by the sine of 0.8. And I get 1.394. And in 13, the secant, you take 1 over the cosine. Secant is 1 over the cosine. Cosine is 1 over the secant. So actually, is that true? Yeah, we have a problem here. Oh, no, we don't. Okay. I don't know why I did that. So that's 1 over the cosine of 1.8. I was thinking that these had to be between -1 and +1, but these are radians, so that's the key thing. Is the secant is 1 over the cosine. Cosecant is 1 over the sine. Cotangent 1 over the tangent. So just have to put that in there. It should work out fine. So here I get -4.40. Remember, the cosecant and the secant are either greater than 1 or less than -1. I don't know if you remember that or not, but that is true. Okay, so it looks like all there is.